Welcome back to the channel, Bridging the Gap, Student to Engineer, where STEM professionals provide advice to students. This video is a request. It's a discipline deep dive into mechanical engineering. We're going to be releasing several of these discipline deep dives in the next week or so, and hoping to hit a lot of the requests that we've gotten recently for discipline deep dives. What I'm also going to do is create some playlists on the channel for each of these majors, so that if you are interested in mechanical engineering, for example, I will also have some schools in that playlist that you might consider if you're looking at mechanical engineering, just to give you some ideas for that major. And then we'll do that for the other majors that we have in discipline deep dives. But if there are some disciplines that you are interested in that you haven't seen yet, please leave a comment and we'll add those to our list. So let's get started with mechanical engineering. Okay, so mechanical engineers, like all engineers, identify, formulate, and solve complex engineering problems. And they do that by applying the principles of engineering, science, and mathematics to do a number of things related to machines. So they design, develop, build, and test machines and other solutions to solve mechanical problems and challenges. They also research, design, and improve equipment and processes for manufacturing products. And then they apply their mechanical expertise to a wide range of problems in areas such as robotics, aerospace, buildings, and the systems that go into those buildings, automotive, construction, biomedical, manufacturing, and a number of different areas. When I think of mechanical engineers, I think of them being the experts in things that move. I'm a civil engineer. Civils typically focus on things that don't move. I like bridges, they don't move. Mechanical would be someone who would design a car that would drive over that bridge, or maybe a boat that would go under the bridge. They also work on, like we said just a minute ago, building systems. So that would be heating, ventilation, and air conditioning systems, plumbing systems, those types of things that make our built world run. Also, mechanical engineering is a really broad major that can go into a lot of different things. It is one of the majors that we recommend instead of aerospace. If you're interested in going into an aerospace industry, mechanical is a way of getting there. Robotics is very similar. And as you look at different schools and their mechanical engineering departments or majors, some of them have concentrations in these other areas, and some of them are just general, but there are a lot of different options in mechanical and a lot of different specialties after you graduate or sometimes when you're in school. So let's start by looking at the career outlook. So this is the 2024 data from the U.S. Bureau of Labor Statistics. According to that government entity, the median pay for mechanical engineers is $102,000 per year. Like all engineering, the typical entry-level education is a bachelor's degree. The number of jobs in the U.S. with a mechanical engineering title is almost 300,000 and predicted to grow 9%, which is much faster than average in the next 10 years. So they're looking at numbers that are well over 300,000 by the end of the decade from 2024. All this is data that I will provide a link to in the description of the video, as well as links to a lot of other things that we're going to be talking about. But I think the takeaway from this, a couple of them, is there are a lot of mechanical engineers around, and they make a good amount of money, and you can get into the workforce as a mechanical engineer with a bachelor's degree. All right, so let's look at industry organizations. So we talk about this on all of our discipline deep dives. Industry organizations are essential for being connected with the rest of the world within your discipline once you start working. But industry organizations are a really good way to explore your major, get connected to professionals, which means connected to jobs, to get scholarships, and to even get connected with other students that are in your same major. So mechanical, because they are so large, has a lot of industry organizations. The primary one in the US is the American Society for Mechanical Engineers, ASME, which is on the top here. And then there's lots of different specialty organizations. SAE is for automotive primarily, but they've kind of generalized themselves, and their tagline now is mobility advanced. So a lot of different things there. Society of Manufacturing Engineers, if you are a mechanical engineer in manufacturing. ASHRAE, which is heating, refrigerating, and air conditioning engineers. Lots of standards coming out of them, and a good way to get connected to people in industries related to HVAC and such. And then we get into even more specialized: Society for Experimental Mechanics, Acoustical Society, Non-Destructive Testing, Welding Society, and then Tribologist and Lubrication Engineers. If you're interested in those types of very specialty things: Combustion Institute, Vibration Institute, and then Association of Energy Engineers. This is a long list. It is not everything, but if you're watching this video and listening and thinking, I never heard about lubrication, that sounds like mildly interesting, it's definitely worth checking out. My experience with industry organizations, particularly as it relates to students, is the more specialized the organization, the fewer students they tend to have involved, and the more excited they tend to be that students are interested in their very specific thing. So if acoustical work seems mildly interesting to you and something you might want to check out, then just go check out the Acoustical Society of America website and see if there's something that's interesting to you there. But definitely check it out now as a student, even in high school before you get into college. There are a lot of opportunities to get involved, or at least to understand what's going on. All of these organizations have conferences, regional or national or international, and you never know, there might be one near you. Typically, if you're a student, they offer very cheap admission, and if nothing else, just go walk around the exhibit hall, talk to people, or just look and get free swag. There are a lot of reasons to reach out and look at these organizations. Okay, so then let's talk about schools. So mechanical is extremely common. It is one of the 4 basic types of engineering. There are over 370 ABET accredited programs. It is the type of major that you can do pretty much anywhere. So there's a long list of schools here. I will provide the link to ABET in the description of the video, so you can look to see if schools near you are on there. But you can sort by location. Just type in mechanical, and they'll all come up. But definitely something that you can get pretty much anywhere you want to go: small school, private school, large school, anything. What I also noticed is that a number of schools that offer general engineering, so those small liberal arts colleges that offer engineering as a major, some of them have a separate ABET accredited mechanical program. So like Olin College of Engineering is one of those. They have a lot of just plain engineering. General engineering is what they're officially called. And we have another video on that, which I will provide a link to. But they also have a mechanical program that is separately ABET accredited. So definitely just understand that you can go pretty much anywhere. Now the question is, do you want to go anywhere? A lot of advice I've seen online is just go to any ABET accredited program and you'll be fine. So what I've done is I've pulled student outcomes for 2024 from 6 different schools. The challenge with pulling outcomes from different schools is that there are quite a number of schools that don't provide major specific data. So these 6 that are on here are not necessarily ones that I would completely recommend, but they are ones that provide the data that we need to be able to just have a discussion specifically about mechanical engineering. So let's just start with the annual grads column. All of these programs are pretty large. If you look at the percent of total engineering, the very smallest is 14%. I would say that the reason it's so small in University of Illinois Urbana-Champaign is because that school has so many different, very specific engineering majors that you can do. And so it's pulling some numbers that would normally just major in general mechanical engineering. So if you're interested in some niche areas of mechanical, definitely look at the University of Illinois Urbana-Champaign. But in this case, with these numbers, we've just pulled the ones that are just straight mechanical engineering without some of those specialty things. But if you look at the rest of these, it's up to 39% of the total engineering at the school, and generally like in the 20s. So it is pretty common. If you're going to be a mechanical, you're going to be a mechanical like everyone else. There's going to be lots and lots of people around you who are majoring in this. But the next column, percent grads with positive outcomes, is where schools differentiate themselves from others. So what this represents is the percent of graduates who within 6 months of graduation are either in a full-time job or in school, grad school, related to what they want to do. Now, some schools count things a little differently, but we're just going to assume this is all counting everything just the way the industry standard dictates they should, which is 6 months after graduation. So if you look at the range here, we range from 76% positive outcomes, which is about 1 in 4 students who are graduating don't have any positive outcome, either a job or grad school within 6 months of graduating, all the way up to 99% positive. So that's a pretty huge range, especially if you're looking at paying a premium for UC Berkeley, and then coming out and having a 76% positive outcome or expectation that you're going to have a job or grad school when you're done. There is a reason to look closely at the school that you're choosing and deciding based on this positive outcome rate. On this channel, we have lots of different videos for various schools. Those all provide links to the school data, and I'm going to provide the links to all of this school data so you can dig into that if you want. But going to your local school does not necessarily mean that you're going to have a lower probability of having a positive outcome. Now, we as humans think it won't happen to me, I'll be fine, I'll be part of that 76% that gets a job. That isn't necessarily the case. When you're looking at an investment like going to school, I would strongly recommend that you not take that approach and take more of a data-driven approach to where you think you might want to go to school. I know that when we were working with my daughter on where she should go to school, we did a multiplier that was the percent positive outcome rate times the median starting salary, and figured that was a good way of multiplying those two factors and getting something that would make sense. So I just talked about median starting salary. Let's just go over there. So Berkeley has a higher median starting salary. They do for every major of engineering, but they are also in a very, very high cost of living location, especially compared to all of the other schools on here. So the rest of them being in the 70s to 80s range is pretty standard across the country for engineering grads these days. The 94,000 is definitely higher, but expected in the Bay Area. So let's just go back one column, percent grads employed. Again, this column has a pretty big range from about 52% all the way up to 70% employed. So this can be good or bad. There are some people who go to school expecting to go to grad school, and so you might want to look at schools that have a higher percent going to grad school. But a lot of people, particularly in engineering, want to just get a 4-year degree and get out and start making money. So definitely look at these percents for the schools you're looking at. If you look over at the percent grads continuing education, you'll see that this is a huge range in this area. Colorado State, only 14% going on to grad school. This is pretty consistent for their engineering majors and their engineering graduates. I think it's odd. That's a very low number. Typically, you'll see in the 20s, like the first 4 schools here. And then for some schools who were very focused on research or have programs within their school that make it very easy for students to continue on to their master's and get a master's in 5 years, they'll have a higher percent. But the 14% is odd to me. And if you are considering going to grad school, look hard at Colorado State. We also have a video just on the data from there, so check that out, and I'll provide a link here. So the message here really is choose your school wisely. Not all schools are created equal. And this is the 2024 data. If we had looked at 2023 data, a few of these would be much higher. I think Purdue was at 99% in 23, and a few of their majors have dropped significantly in 24. So we don't know what's going to happen with the 25 data that should be coming out in the next 6 months for most schools. But definitely look at your school and choose something that's going to give you that assurance that once you graduate, you're going to have a job or be able to go to grad school. Okay, so let's talk about if you do graduate, when you do graduate with a mechanical engineering degree, what kind of companies hire mechanical engineering grads. So these are from actual schools that talk about or share data about where grads are going in terms of what companies they're working for. I've ordered these somewhat by industry. So just starting out with cars, lots and lots of motor vehicle companies hiring mechanical engineers to do lots of different things. And then related to that, because it's also moving, is space. So SpaceX and Blue Origin, Boeing. Then you start getting into defense. So defense and space is often considered one industry category. The last one on this left column is General Dynamics Electric Boat, which is a cute name for something that's not electric boats. So if you're interested in that, I definitely encourage you to go Google it and find out why they're not electric boats. But once we get over into the right column, we get into a lot of different types. So Apple, which is consumer goods, John Deere does farm implements, Eli Lilly is a pharmaceutical company, and then Carrier and Honeywell do HVAC systems. Caterpillar, similar to John Deere. And then there's a number of construction companies, engineering, design, and construction companies, Milwaukee Tools, MIT Lincoln Labs. So lots of different things. And there is a reason why there's such a large variety of companies here and such a large number of mechanical engineering grads graduating all across the country. You can have your pick of industries. The nice thing about mechanical, rather than majoring in something that's very specific like aerospace or robotics, is that you have the opportunity to cross lots of different industries. And so if one of the industries isn't going well or not hiring when you graduate, there's always going to be other industries that are looking for people just like you. So once the grads get to those companies, what are their job titles? So this again is from actual school data. I'm not going to read all of these, but essentially they're all related to mechanical engineering. So you're a mechanical engineer, systems, maybe you're testing things, working on a propulsion system, leading projects. Field engineers are essential for construction projects, and various disciplines are needed for that. Engineering in manufacturing. And there's continuous improvement leader and process engineer. These are good ones that typically will take a wide variety of majors in engineering, but looking for people who have an eye for improving the way things are done, and being able to implement tools like Six Sigma and Lean and those types of things to improve the way the company works. So definitely a lot of different options and a lot of different ways of applying a mechanical engineering degree. So resources, where can you go from here? You can always just Google engineering, mechanical engineering resources for high schoolers or college students, whatever your level is. There's a few that I like to recommend. Engineering Expectations is a small woman-owned business that's an engineer helping students with deciding if engineering is for them and the different disciplines that are available within engineering. They've got a website and workbooks and other things that are really helpful. The description of this video has a link to that website. And then ASME, which is the American Society of Mechanical Engineers, has a STEM Careers Coalition. This is focused on helping educators and parents, but also just has some good resources for students. So definitely good to check that out. And again, I will provide the link in the description. Right, so that is the end of our deep dive into mechanical engineering. If you have any questions, please leave them in the link in the comments for this video. Please like the video, subscribe to the channel, share with a friend, and we'll see you on the next one.